In this lesson, we're going to look at how we multiply powers together. So we're going to start off with a small example here. X cubed times x squared, and let's think about what this actually means. X cubed means that we have x times itself 3 times. And x squared means x times itself twice. And what's a better way to write this? Well, we have x times itself 5 times. So x to the 5th power. And how can we go in one nice, sweet, wonderful move from the original multiplication problem to the simplified answer, x to the 5th? I'm hoping that you might see that, hey, we're really just adding the exponents, and that leads us to a property of exponents that says when we have a power, 2 powers being multiplied together, where the bases are the same, so the base is a in both of these. If the base is the same, we can just take the 2 exponents and add them together. So in words, this property is saying if we're multiplying 2 powers with the same base, add the exponents together. In this short video, we're going to go through 4 examples illustrating how we can use this idea in some different problems. So let's simplify this expression. We have 4 times z to the 5th times 9 times z to the negative 12th. Well, one thing that we have to remember about multiplication is that the order doesn't really matter. So we could actually rearrange this. It's 4 times z to the 5th times 9 times z to the negative 12th. We could rewrite it as 4 times 9 times z to the 5th times z to the negative 12th. Well, 4 times 9, we know that. That's 36. And then what we just saw with this property says that we can take these 2 powers that both have a base z and add the exponents together. So it's 36 times z raised to the negative 7th. And you might be tempted to stop here, but if we're simplifying expressions, we never want to leave an exponent that's negative in the problem. So this goes back a couple lessons ago. The 36 does not have a negative exponent. That's going to stay in the numerator, but the z does have a negative. So that power z to the negative 7th is going to go from the top here and drop down to the bottom to the denominator. And what's doing that is the negative exponent right here. So we use that up and it becomes z to the positive 7th. So here's a second example. This one's a little bit bigger than the last one, and there's 2 different variables in it now. I'd like you to pause the video and write down what you think this simplifies to on the paper sitting in front of you. So remember, this is 2 times a, 2 times a, times 9 times the power b to the 4th, times 3 times a squared. So what we can do is we can take all of these coefficients, 2, 9, and 3, and multiply them together. 2 times 3 is 6, times 9 is 54. So that's coming from multiplying the coefficients of these together. Now we look at the powers. So we have a and a squared. Remember, this is a to the 1st. So a to the 1st times a squared becomes a cubed. We add those exponents together. The b cannot combine with this because it has a different base. So our simplified answer is 54 times a cubed times b to the 4th. Our third example looks a lot like the second example. We've got some different pieces. We need to multiply and simplify this. So again, pause the video and try to write down what the simplified form of this is. Again, we can take the coefficient parts, the negative 4, the 2, and the 7, and we can multiply those together. That gives us negative 56. And then we look for the powers that have the same bases. Well, we have c cubed and c to the negative 2nd. Since the bases are the same, we can add those exponents. We now have 56c to the 1st, and we actually don't need that first power. And we're still multiplying by d squared because there's nothing else to combine that with. And here's our simplified form. Negative 56 times c times d squared. In our last example today, we're going to multiply two scientific notation numbers together. And when we do this, we want to give our final answer also in scientific notation. And this problem is really no different than the previous examples. We have 3 times a power, 3 times a power, times 5 times another power. So we can take the 3 and the 5 and multiply them together. We get 15 times 10 to the what? Well, these powers have the same bases, so we take the exponents and we add them together. And we might be tempted to stop here, but you might remember that this isn't a scientific notation number because of the 15. The 15 is bigger than 10. So we need to do a little bit of changing with that. We need to think about what's 15 in scientific notation. Well, it's going to have to be 1.5 times 10 to the what? Well, the decimal moved over 1, and this is not a decimal value. This is a big number, so the exponent would be positive. So 1.5 times 10 to the first, and then we still have times 10 to the negative 7. Now we can take those two, the two powers. Again, we have two powers. They're both base 10. We can add their exponents, 10 to the negative 6th. We have 1.5 times 10 to the negative 6 as our final answer. These are questions that you can simply drop into your calculator and let the calculator do it for you, but that should be something that you're using as a way to check your understanding of how to work with exponents and multiplying powers together. So there we go. We're stopping. That's all there is for today. In the next section, we'll be looking at how to divide powers.